So let's look at compound interest. Okay, so interest can come in different forms and depends, I suppose, on the question and depends what you're looking at. So in some cases, we might be looking at the interest that's charged on or that's earned on like a savings account. So when you're putting your money into savings, you earn interest on that. So your savings are increasing then. It might be the value of a loan that you've taken out. So if you take out a loan, you'll have to pay interest on that loan. So it's working out maybe how much are you paying back in the long run. Things like savings bonds, as we said there, stocks, things like that. All of these things is that you're earning interest upon that's going to increase it. So when we're calculating interest, what's important to do is take 1 year at a time and note any changes that are made. So if there's a change to the interest rate, if there's a change to the amount that's being charged, if there's a change to anything, if they've taken out money after 2 years, if they put some more money in after the third year, you have to be really, really aware of all those changes that are happening. So looking at an example here gives us a good idea. So Lizzie invests €10,000 in the savings account for 4 years. She earns interest annually, so every year at a rate of 5%. After year 2, the interest rate increases to 7%. The end of year 3, she invests an additional 2,000. Calculate the total interest that she's earned at the end of 4 years. So let's go through it year by year. Starting with year 1. So for year 1, she has 10,000 in her account and she earns interest of 5%. So her interest for the first year is going to be 10,000 by 5%, which gives me €500. So at the end of that year, she has €10,500 in her account. Okay, so that increases. Remember we said at the start, so when you earn this interest, that increases the amount that you have in your account. So now at the end of her first year, she has more money than she started with. That's kind of the goal of a savings account. So at the end of year 2, nothing else has particularly happened yet. So we're started the year with our 10,500 and my interest again is 5%. So my interest at the end of that year is 525, which means at the end of that year, I have a grand total of 11025 in my account. Okay, we're told at the end of year 2 or after year 2, the interest rate increases to 7%. So for year 3, I have my 11,025, but my interest this time is 7%. Okay, so this is what I'm talking about noting the changes that happen from year to year. And you see how we're just laying everything out nice and straightforward, nice and methodically, and keeping it just kind of straightforward the entire time. So at the end of that year, I have €11,796.75. Now, in the question, we're told at the end of year 3, she invests an additional 2,000. So that means that we have to add that 2,000 on to what I have at the end of that year. And that's going to take me into the next year. So at the start of the next year, I'm actually starting with €13,796.75. So let's go for year 4. So that's what I'm starting with, 13,796.75. My interest rate we're assuming is still 7% because that's what it increased to. And my interest for that last year is €965.77. And I can add those together to get my total interest that I've earned on my initial investment, €2,762.52. So that's the total interest that Lizzie has earned across the 4 years that she's invested that money for. And we could also have worked out our end result at the end of those years, at the end of the 4 years. So adding on that interest to work out what I have at the end of the 4th year, which is 14,762.52. And that again, I suppose, would lead us in the same way to work out what we have earned on our interest. Now that's working out as more. So that's working out as 14,000. So if we change the change here in that, the difference between those. So if we take away the 10,000 we started with, so I'm showing myself thinking about it, which is a good idea. The difference there obviously is 2,000, and that's the 2,000 that we invested. That's the 2,000 that we invested here because we've added in 2,000, so there's a 2,000 extra difference. So adding up the interest is the quicker way to do that. Okay, I was starting to doubt myself there, but that's where the extra 2,000 is coming from. So let's look at an exam question then, following the same idea. So a deposit account earns 3% interest in the first year, 6% in the second year. The interest is added at the end of each year. If they invest 20,000, how much will they have at the end of 2 years? So let's focus on year one. So for year one, they've invested 20,000. The first interest rate is 3%. And that gives me 600 euros. So at the end of that first year, I have a grand total of 20,600. Now, the other way we could do this, because we want to know how much we're going to have in the end of each year, we could say, well, I'm going to have 3%, or I'm going to have what I started with plus my interest, which is 3%. So that gives me a total of 103%, kind of like we did before with those increases by increasing, or percentage increase, I should say. And that just will quickly jump me to what I have at the end, which is 20,600. Okay, doing the same for year two then, so we can do it both ways. So I start with 20,600. My interest rate now is 6% for the second year. So getting the interest on that one is 1,236, and that means that at the end of the year, I have 2,1,836. And similarly, if I took it the same way, the 20,600, and did 106%, because I want to find the original plus the 6% extra, I'm increasing by 6%, we can see that I get the same amount. I get the same amount each time. So if they invest 20,000, how much will they have at the end of the 2 years? 21,836. We should have our euro sign there to keep it consistent. Okay, so pushing on a little bit more. So when we're looking at these questions, we've seen in the past too, in kind of the example in the exam question there, that what happened a lot of the time was maybe we were changing the interest rate, or they were putting in extra money, or they're doing something like that. If we have a case where they've invested their money and we are given the interest rate and there's no change, they don't take any money out, they don't change the interest rate, it just stays the same for however many number of years, then what we can do is we can use this formula. And this formula is in your log table. See, it's not one that you need to know off, but again, you need to just know that it's there and know how to use it. And it's your compound interest formula, where F is what we call the final or the future value. P is called the principal, which you can nearly think of as like the present value. So that's the amount that you invest. I then is our annual interest, and T is the time in years. Okay, so I is your interest, annual interest is for year, and T is also my time in years. Okay, so that's kind of in the notes there. So the second one, I said the interest rate matches the length of the time. So because my interest is in years, my time is in years. And this formula can only be used where the rate and amount do not change. So both the rate and the amount have to stay the same. So it can't be that you invested extra money after a certain length of time, or you'd have to adjust how you do it. You'd maybe only do it up to that point to put the money in and then continue on. Or you can't change the rate. So you could only use it maybe for the years where the rate was the same. So you can kind of adjust it to suit if you need to, but really this formula should only be used where maybe the rate's going to stay consistent and you've invested a certain amount and we want to work out the value at the end. So looking at an example here, 29,300 was borrowed at a rate of 6% for 3 years. So I'm paying interest of 6%. Calculate the final value. So final value is what I'm looking for. My principal is the amount that I've invested, which is the 29,300. My interest rate is 6%, and my interest rate has to be put in as a decimal. Okay, so that's something worth noting here. It should be as a decimal. So I have to put it in. 6% would be 0.06, and T is my time in years, and I'm putting it in for 3 years. So subbing all of those points into my formula then, 29,300, 1 plus I gives me 1.06 for 3 years, and I can just sub that into my calculator then to get my answer. And I get 3489677. And that is the amount of money that I would have at the end, or that's the amount that I would owe at the end, I suppose. To work out the interest then, I would take that final value and I would take away what I invested, because any change, any increase in that would have to be the interest. So I can work out that the interest is 5596.79. That seems slightly off. Let me double check that. There we go. We're still using the full answer from the previous one. So 5596.77 as my answer there for the amount of interest. So that's the interest to be paid. And the final value then is this value here, this value for f. Another way this could be asked would be looking for the present value if we're given the value after a certain length of time. So here we're asked to find the amount that needs to be invested at a rate of 4% to give 2,500 in 5 years' time. So again, let's summarize what we have and what we're looking for. So I want to find how much I'm investing now, which is the present value, the value at the minute. I want the future value to be 2,500. That's what I want to have at the end. The interest rate is 4%, which is the decimal is 0.04, and the time is 5 years. So subbing that into my formula, we're leaving P unknown. This is 1.04, and for 5 years, P is 2,500 over 1.04 to the power of 5. And again, then we just can sub that into our calculator to get our answer. And we get 2054.82. So €2,054.82 needs to be invested, and that would give me €2,500 in 5 years' time. Okay, so looking at an exam question of these, then we'll do I think two exam questions. Yeah, one longer one. So looking at this first exam question, a sum of €5,000 invested in an 8-year government bond with an annual equivalent rate of 6%. Find the value of the investment when it matures in 8 years' time. So let's see what's important here. 5,000 is invested, so that's put in at the minute, that's the present value, that's the principal. 8 years, 8-year government bond, so that's my time, so it's a length of 8 years. My rate, my annual rate is 6%. We want to know the value of it in 8 years' time, so I'm looking for F. My principal, we said, was 5,000. My 6% becomes 0.06, and I'm putting it in for 8 years, and then I can simply sub this into my calculator. And I get 7969.24. So €7,969.24. Okay, and this was a part A of a question, so obviously as they go on, then you might be asked to give more and more information, and they might change different parts of the question. So here, a nice full long question. So Paul has 8,000 that he wants to invest for a maximum of 3 years. His local bank is offering 2 options as shown in the table. Find the value of the investment at the end of 2 years if he chooses option 1 and does not take any money out. Okay, so let's have a look. So he's investing 8,000 and we want to know the value at the end of 2 years if he chooses option 1. And option 1 is this here. So 2% interest in year 1, 3% interest in year 2. Okay, so let's write those down. So year 1, so we have 8,000 because that's what we've put in. It was 2% interest for that first year. So that gives me €160 of interest, and at the end of the year I'll have a total of 8160. Then for year 2, so I start with what I finished the last year with, 8160. My interest rate now is 3% for the next year. So my interest for this next year is 244.80. And at the end of that second year, I will have 8160 plus the 244.80, which gives me 8404.80. Okay, at the end of that second year. Okay, find the value of the investment at the end of 3 years if he chooses option 2. So for 3 years, for option 2, it's a rate of 3.37% compound for 3 years. Now, compound is what we're looking at here. It's where it just means the interest is added on. So here we can use our formula because our interest rate isn't changing. We're not taking out any money. I'm looking for the future value. I put in 8,000. My interest rate was 3.7%, which as a decimal is 0.037, so 1.037, and we're putting it in for 3 years. And again, we can just use our calculator then to work that answer out for us. We get a value of 8921.26. So 8921.26 for part B there. So let's have a look at the next part then. Give one issue other than the rate of interest earned that Paul might take into account when deciding between option 1 and option 2. Well, I would say that the one issue that we can see there is taking money out. So for option 1, he can take out money after year 1 or year 2 without any penalty. For option 2, he can only take out money at the end of year 3. So that would probably be something that he would take into consideration. Paul would like his investment of 8,000 to amount to 9,000 after 3 years. What annual rate of compound interest would be required for this to happen? Okay, so he wants the 8,000 to be 9,000 after 3 years. What would the rate have to be? So he wants the future value to be 9,000. He wants the principal, the present value, to be 8,000. We're looking for the rate of interest and the amount of time. He wants this to happen after how many years? 3 years. So again, we use our formula, we fill in the bits that we know. We know what F is, we know what P is. We don't know what I is, and we know that this is 3. So continuing, 9,000 divided by 8,000, 1 plus I to the power of 3. Okay, so 9 over 8. And we can use the cubed root, or the same thing as doing to the power of 1 over 3. So I is 9 over 8 to the power of 1 over 3 minus 1. So I is, let's double check here, 0.04. Okay, so a rate of 4%. So a rate of 4%, and we're told to give it as a percentage, so that's 4% then. Looking at part E, another bank offers to invest his €8,000 in a special fund. The bank has found that in short term, the amount of money in this fund follows this formula. So this formula V, where V is the value of the fund in euro and T is the time in months. So that's going to be important since the money was invested. Find the value after 12 months. So we're using this formula. So let's have a look. So we're in part E. So V is 8,000 plus 36t minus 1.2t squared. So we have a nice kind of quadratic formula here that we're using. We're asked to find the value after 12 months, after 1 year. So we're subbing in for t, 12, because we were told that t here stands for the time in months. So 8,000, 36 by 12, plus 432, minus 172.80. 8,259.20. €8,259.20. Mary invests 8,000 for 1 year at % per annum. After 1 year, her investment is worth the same amount as that answer that we got in the first part. Find the value of or correct to 2 decimal places. So at the end of 1 year, her investment is worth what we have here, 8,259.20. So or percent of her investment is worth that. So we have a few different ways that we work this out. We could use our formula. Okay, so the future value of her investment was 8,259.20. The present value of her investment is 8,000. Her interest rate is or, and the time is 1 year. So we could sub everything in here. Okay, and we get 8,259.20 over 8,000 minus 1 is equal to or, and or is 8,259 gives me a rate of 0.03, or we get 3%. So if she invests it for 3% for 1 year, that will be her value at the end of the year. And we're asked to give it going a bit too small with that. So it's 0.0324, which as a percentage to 2 decimal places is 3.24%. So that's her accurate rate that you would need to invest it at in order to get that value out. So the key thing, I suppose, with all of these is making sure that you're happy with that formula, first of all. So that's this formula here for compound interest. As we said, that's in your log tables. So you just need to be sure that you know what each of the letters stands for. It does say it in your log tables as well. But know that you can only use it where the rate doesn't change, where the amount invested doesn't change. Otherwise, you need to lay it out as we did here, laying out each year at a time. And that can seem time consuming, but it's actually fairly okay. Particularly if you were to use like this one here, where we just jump straight to the value at the end of the year, and that's using that 103%. Or if we kind of note as well, 103% is the same as 1.03, multiplying by 1.03, which is where it comes from in our formula. So taking that 20,000 and multiplying by 1.03 would give us the same answer. So being able to do that can be fairly easy, fairly handy for you, I suppose, because you can jump straight to kind of the end of the year and the value at the end of the year, and we can use that then to work out the interest by taking away what we had at the start. But those two things, so either doing it laying out year by year or using your formula here and using that then in calculating the present values, future values, and laying out like we did there, lay out all the letters so that you know what each of them stands for, and then you'll be able to sub them in a bit easier for yourself.